channel. Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics, that has been your class 11 part 1, which we had even started in the last classes. And this is your class 8. Class 7 we had done, where we had completed your unit 1, and we had started even though unit 2, which is your units and measurement. And lastly we had done your question that we calculate the angle of degree, and 1 minute as well, so and 1 second, for using the values that we had done. You can go ahead with last classes and you will find it out, all the questions and all the topics that we had done in the last classes, which is being related to the parallax method as well. So we continue with this only, and we'll start with another question, and that is the another second question of the sessions here. The question we have here is: a man wishes to estimate the distance of a nearby tower from him. He stands at a point on A, in front of the lower C and the spot of the very distant object 0, which is O, in a line with AC, and he then walks perpendicular to AC up to B and a distance of 100 meters, and looks at O and see that again, since O is very distant, the distance BO is practically the same as AO, but he finds that at the line of sight of C, that shifted from the original line of sight by an angle theta, which is equals to 40 degree, and theta is also known as parallax, that to estimate the distance of the lower C from the original positions A as well. So we go for the same here. Let's find it out. The question we have: a man wishes to estimate the distance of a nearby tower from him. He stands at a point A in front of the tower C and spots a very distant object O in line with AC. He then walks perpendicular to AC up to B, a distance of 100 meters. And looks at O and C. Again, since O is very distant, the direction BO is practically the distance the direction BO is practically the same as AO, but he finds a line the line of sight of C shifted from the original line of sight by an angle theta equals to 40 degree. Theta is known as parallax here, so you have to estimate the distance. Need the distance of the lower C from the original position. Okay, A. So we got to find it out here. Let's go for the solution. So here we have a diagram for it. We made it. That they had told you that is the distance between A and C that has been apart. A and B. Then it is being extended here. So this is the point C where it's gonna be merged here. This is the theta. This is 100 meter apart as I told you in the equation. This is also being the theta here. And this is a distant object. So now we go for the same and we'll find out the solution here, and that is important. Let's find it out here. So we have parallax angle, which is your theta, and that is equals to 40 degree. So from this, as you can see here, AB equals to AC, which A tan theta, AB equals to AC tan theta. So that is equals to your AB equals to AC tan theta. AC equals to AB upon tan theta. And we find out the value of AC, which is AB, you know very well, 100 meter upon tan 40. Theta is your 40. So 100 meter per tan 40 is your 0.8391. So it will give you 109 meter. That is the value, and that you have to find it out here. Now we go further and we'll do another question here. That is also been an important one. And the question, the third question of the session of this particular unit 2. The question we have here is that the moon is observed from the two diametrically opposite points A and B on Earth. The angle theta subtended at the moon by the two directions of observation is your 1 minute 54 second. Given the diameter of the earth to be about 1.276 into 10 to the power 7 meter, you have to compute the distance of the moon from the earth. So let's find out for the same, and we'll go for the same as well. The moon is observed from, so where we go, the moon is observed from two diametrically opposite points that we have here. So that the points we have diametrically opposite point A and B on earth, A and B on earth here. So the angle theta subtended at the moon by the two directions of observation is 1 minute 54 second. Given the diameter of the earth to be about 1.276 into 10 to the power 7 meter, compute the distance of the moon from the earth. Let's find out. Here we have theta equals to 1 minute 54 second, which is equals to 114 minute, and so we convert that 114 into 16 into 4.85 into 10 to the power minus 6, that, and that will give you 3.32 into 10 to the power minus 2, right? Okay, now since that is your 1 minute equals to 4.85 into 10 to the power minus 6 rad, and also now that we have your P equals to AB, which is equals to 1.276 into 10 to the power 7 meter. So hence from this we have the earth moon distance, which is equals to D equals to B by theta, which is 1.276 into 10 to the power 7 upon 3.32 into 10 to the power minus 2, which will give you 3.84 into 10 to the power 6 meter. This is how you have to find it out, and yes, you have to go through with this, and these types of question is being asked in your examination paper, and this has been possible for the same, that when you are going to practice more and more, and then only you are able to solve these type of a question in an easy way. And today we have your numerical class mostly, and so we'll continue with this only. And then after that we'll discuss about some of the theories related to the estimations of very small distances, size of a molecule, which has also been important one. Let's go further here. The next question we go ahead, and that has been another question. Let's do that. And the question we have here is, that is being as follows. Let's go for the question. The question is that the sun's angular diameter is measured to be 1920 minutes. The distance d of the sun from the earth is 1.496 into 10 to the power 11 meter. What is the diameter of the sun? That what we'll have to find out, and let's go for the same. Here we go. The question: the sun's angular diameter is measured to be 1920 minutes. The diameter d of the sun from the earth is 1.496 into 10 to the power 11 meter. What is the diameter of the sun? Since we go for the same, and sun's angular diameter alpha, that is equals to 1920, so it will be 1920 into 4.85 into 10 to the power minus 6, that will give you the value here as being 9.31 into 10 to the power minus 3 rad. Now sun's diameter, that is your d is equals to alpha d equals to 9.31 into 10 to the power minus 3 into 1.496 into 10 to the power 11 meter, which will give you 1.39 into 10 to the power 9 meter here. Okay, that has been the question that what we have to solve it out here. Now we go for some of the related to the theories as well, but that we'll discuss in the next coming class. That has been the estimations of very small distance, size of molecule, and many more related to their numerical, as well as the range of the lengths as well, the measurements of the masses, range of the masses. That all we'll discuss in the next coming class. And I hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In talking about this, in physics part 1 for class 11, we had done your unit 1, where we had done your that has been the first unit, and which we had discussed about in the last classes, as I told you, and that you have to go ahead because the one unit has been completed. The name of the unit is your physical world. Here we had completed what is physics, scopes and excitement of physics, technology and society, and of course the fundamental forces in natures of physical law as well. In this unit, which is unit 2, we have to discuss, that is units and measurement. We have to complete it, introduction and the international systems of unit, the measurements of length, measurements of mass, measurements of time, accuracy, precision of instruments and errors in measurement, significant figures, dimensions of physical quantities, definitions of dimensional formulas in the dimensional equation, dimensional analysis and its application. And then after completing this, we'll further continue with motions of a straight line and many more units chapters we have to cover up here. In the part 1 we have your 8 velocities of gravitation. So we'll go and end up with, we'll continue with the next coming class. Thank you. If you enjoy this video, if you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.